chemistry, like taking in our in-depth look at states of matter, you guys are undoubtedly aware that elements that are in a certain state don't always stay in that specific state of matter. That states of matter can change. We call these changes of state. And you will need to know these terms. Let me just see what this little picture is about. Oh, got it. Okay. Bring that here. Okay, so let's talk about condensation. Remember condensation last year from biology in our little water cycle song, evaporation, condensation. What was the condensation part? Well, condensation part was if you said when a vapor, a gas state, goes back to a liquid state, then you were correct. So condensation is a process by which a gas changes to a liquid. That gas is called a vapor when the gas is in contact with its liquid or its solid phase, which is most often the case because we have something called a state of equilibrium going on. Equilibrium just means we have a situation where you have two opposing processes and they are occurring at equal rates. One might go faster than another for a certain amount of time, but eventually those two opposing processes are occurring at equal rates in a closed system. So at any time that we have a liquid, we have evaporation happening, which is the opposite of condensation. Evaporation is those liquid particles turning into gas particles. So evaporation, condensation, two opposite things. But anytime you have a liquid in a closed container, there's a certain amount of evaporation going on. And as you have probably witnessed, there's also a certain amount of condensation going on when you cover. In fact, I think I'm going to have you, I think I might have you do a little activity about that. So I'll leave it at that for now. All right, so this equilibrium, here's a pretty good picture. All right, so we've just input our liquid into our container here, our closed container. Okay, this is what our liquid looks like, time zero. We just poured water, let's say, into this graduated cylinder. Before equilibrium is achieved, that liquid water immediately starts evaporating. We talked about evaporation. Evaporation is when these surface molecules collect enough energy that they actually turn into gases. And so before equilibrium, we have some evaporation happening. Okay? But also, when these things reach far enough away from the liquid, they are losing energy, right? Especially in this closed system. They can't escape, so they're in this closed container. All right? And when they get far enough away from the liquid, they're losing energy. And as they're losing energy, they're clumping back together and condensing back into a liquid. All right? When the rate of condensation is equal to the rate of evaporation, we say that equilibrium is established. Okay? All right. All right. We have something called equilibrium vapor pressure that you need to know what that is, abbreviated EVP. And the equilibrium vapor pressure is the pressure when equilibrium is established between a vapor and its liquid. So whatever pressure that this happened for this particular liquid in this particular container, whatever the pressure is inside that container is the equilibrium vapor pressure. Okay. All right, so that was condensation. Now let's look at boiling. We talked about the difference between boiling and evaporation. Evaporation is what's happening to just the surface molecules of a liquid. They're getting enough energy to escape the liquid phase and go into the gas phase. but we're just talking about surface molecules. Boiling happens when we're inputting enough heat energy into a sample of a liquid that even the atoms and molecules at the bottom of the container have enough energy to turn into a gas, and they do escape. And as they're doing that, those are bubbles, right? That's what bubbles are, as gases going through a liquid. So boiling is conversion of liquid to vapor within the liquid as well as at the surface, not just evaporation. The boiling point is the temperature at which the equilibrium vapor pressure of the liquid is equal to the atmospheric pressure. I'm hoping to have a little activity about that to better explain that. We are going to be doing some problems with molar enthalpy of vaporization. What is molar enthalpy of vaporization? Good question. It is the amount of energy needed to vaporize an entire mole of a liquid at that liquid's boiling point. All right. How much energy do you have to input into a certain liquid, 1 mole of it, to vaporize it at this temperature? And we're assuming constant pressure. All right, you are familiar with freezing. Freezing is when we have a liquid turning into a solid, and we do that by removing heat energy. All right, so freezing is a physical change from liquid to solid, requires removing of energy or heat from that liquid. And we had molar enthalpy of vaporization. Now we have something related, but it's molar enthalpy of fusion, but it's very similar. It is the amount of energy required to melt 1 mole of a solid at the solid's melting point. So both of these are about moles. You have to have a mole of the sample. Sublimation, we talked about this freshman year with comets. This is when we have a situation where we have a change directly from a solid to a gas, which is what carbon dioxide does really well. The difference between its freezing point and boiling point is minute. And what we see is we have solid carbon dioxide or dry ice, and immediately vaporizes and turns into the gas form of carbon dioxide. That's called sublimation. And deposition is the opposite of sublimation. So we have evaporation, the opposite of condensation. Deposition, the opposite of sublimation. That's when we have the gas going directly to the solid. All right?